Hey guys, today I'm going to be solving this Leetcode problem 926, flip string to monotone increasing. I'm going to be doing this in JavaScript for all my JavaScript people out there. Okay, so the question's asking a binary string is monotone increasing if it consists of some number of zeros, possibly none, followed by some number of ones, also possibly none. You are given binary string S. You can flip SI, or you can flip each index of S, changing it from 0 to 1 or from 1 to 0. And so you need to return the minimum number of flips to make S monotone increasing. Okay, so you can see example 1, the input is 0, 0, 1, 1, 0, and the output is 1. So the answer is 1 because we can flip this last one to make it monotone increasing to get this number. Example 2, you can see the answer is 2 because we can either flip these two zeros or sorry, yeah, we can flip these two zeros to ones, or we can get this by flipping this to 1 and this to 0. And then this last one, you can see, okay, well, we could flip these three last zeros to ones, but what they're doing is actually flipping these two ones to zeros, because in the problem statement, it does say that there could be all zeros or there could be all ones. That's valid as well. So the approach to this that I'm going to be taking is kind of what we were just talking about. So looking at, okay, first two options are we can make everything zeros or everything ones. So first great step would be to count up all the zeros and all the ones. So count all zeros and all ones to find total totals for each. And then once we have that, that kind of gives us a good baseline for something like this case, right? Like if we want to switch these two ones to zeros, then we know that there's two ones. So we know that that two is less than any other combination to switch the rest. And then the next step is a little more complicated, and that is to solve something like this case, right? Or this case, the first one where we have to actually flip and get a combination of zeros and ones in the final answer. And so the way that you can look at this is, right, the main pattern that we want to see is that when we get to a 0 or a 1, if we see a 0 and 1 in the string, so we can iterate through, once we see that, we know that that's kind of like the starting point for where it would start increasing, right? Because we know it's monotone increasing. So there's never going to be like a 1, 0. That's not going to be valid. We want to find like that pivot point. So when it goes from 0 to 1. And then we know that once we find a 0 or 1, we can count both the number of zeros that come after it, because we know it's going to have to switch, because you know everything that comes after that 0, 1 pivot point is going to have to be a 1. So that's to the right. And then we're going to count to the left the number of ones, because we know everything to the left needs to be 1. Right. So we can look at that for the second example too. So we hit this at 0, 1. We know, okay, first spot, that's kind of like a pivot point. And then we can count, okay, how many zeros come to the right of that? Because those need to be flipped. So we see 1, 2, right? So that gives us this answer. And then look, there's a 0, 1 here as well. So we're going to count all the ones to the left that need to be flipped and all the zeros to the right that need to be flipped. So you can see here, 1 and 2. And then this gives us this answer here. So yeah, so we're going to count all the zeros and all the ones. The next step, we're going to iterate through and find like 0, 1 pattern. And then we're going to count all the zeros to the right and ones to the left. Okay. Once we do that, we know that we just want to find the minimum of all these answers. So we want to either find min of the total zeros, total ones, and like the sum of this part here, like the minimum of the step. Hope that makes sense. So now we're going to start. And so we're going to want to do something like let total zeros equal 0. We're going to do, we want something to hold the total number of ones, right? We're going to want, so yeah, let's just start with that. So here we're going to say, this is going to be where we count the total number of zeros and ones, right? So here we can just simply iterate through that string. And then we're going to say if what we're looking at is equal to 0. I can just probably do this on one line to save space. We can do total zeros plus plus. Oops. And then we can do if it's equal to 1, total ones plus plus. Okay, so that's simple enough. Now the second part is a little tougher, not super complicated though. So for this one, we're going to want to iterate through, and when we find that 0, 1 pattern, we're gonna count the ones before and the ones after. And so you're gonna see, since we already have this total number of ones and total number of zeros, it's gonna be easy to figure out what comes after because we can just subtract. So let's do find 0, 1 pattern and count zeros to the right and ones to the left. And I'll just say it like this. The total is the number of flips necessary. Okay. So now we're going to do the same thing again. Let's iterate through this here. And then, right, we want to keep track of every number ones before this point, right? So let's do if I'm just going to copy this because I'm lazy. This, but right now we want to keep track of the current zeros and the current ones instead, right? Okay. So just going to trade these in for here. Okay. So now let's see if there's a pattern of the 0, 1. So let's just do if s of I, so the current address we're at is 0 and si plus 1. So the next one is equal to 1, right? Because it's going to be like that 0, 1 pattern. Then let's do add that flips, right? Let's figure out the flips. So let's do let the current flips necessary is going to be equal to, right? We're going to do the current ones. Those are all the ones that we've seen up to this point. Plus, and then how we can figure out all the zeros to the right is we're just going to subtract the total zeros minus the current zeros. Okay, and then if that's the case, so okay, now let's put in the logic to find the or keep track of the minimum. So here we can do let min flips is going to be equal to math dot min. So it's gonna, let's just start it out as like the minimum of like these two variables, right? Because these are the cases for if we just want the whole string to become all ones or all zeros, like in this case here. So we would get that minimum 2, and then it would go through all this stuff and we would find out that 2 is that still minimum. So here, after we find the current flips, let's then make the min flips equal to the math dot min of the min flips that we have so far, and then the current flips that we just found. Okay. Now we're just going to return the min flips. Let's run this. I think my computer just froze, but okay, so that is accepted. Now let's submit it. Okay, so it passes all 28% faster. It's not the best, but I hope that this was easy to understand, because I remember the first time I looked at this problem, I was pretty confused by the solution. That's all. Thank you.